Okay, so we did a quick board clear. So I wanted to kind of think about that last graph we had, that value model. And we were showing this increase in money supply pushes our value down. We called that inflation. So I want to kind of think about that. And then think about the graph I had that was kind of here in the middle of the board that was showing what the Federal Reserve had been doing, right? Money supply, money supply, money supply, money supply, quantitative easing. And we said effectively from 2006-07 range to about 2015, that's kind of their goal. Recently, that's been their goal. So are we seeing massive devalue in currency? Right? What I kind of did was just took that middle graph with all those different money supplies and said, what if I put it on a value graph where I have buy bonds, quantitative easing, and it's saying value of money is tanking and inflation is current. Is that what we actually see in society? Because I think that's important to address. And the answer is, I guess, kind of it depends. Maybe not. We actually may not see this huge impact in inflation, and this huge drop in monetary value. So we'll give the kind of the whole big story and the map and stuff here in a second. Some of it too, just because some of you are really visual learners. Keep in mind, that graph isn't showing me anything happening to money demand, where money demand could be pushing that value back up. So that's something that we want to think about, and that's kind of our segue into this next kind of thought. We've seen how the Federal Reserve can change money. We've seen a potential impact on value. So now the next question is, what can money do? What can money do? To answer that, we're going to start out with kind of a flashback for what non-SLU students would consider a flashback. SLU students have never seen this before. Just kind of keep in mind a reminder that SLU doesn't do a principles of macro course, or most places do. So what I'm going to go through here initially is the principles of macro version. If I just jump into the intermediate version, I think it might be a little much. Our textbook assumes you already have the principles version, assumes you've already played with this equation. They jump right into the intermediate version. So for the first few minutes here, probably again, for some students, if you took macro at like the community college or whatever, it might be a flashback. I don't think anyone at SLU would have came across this in their Econ 1900 class though. So to kind of answer this, we're going to start with that principles take on it. What can money do? Using what is called the equation of exchange. The equation of exchange mathematically is MV equals PY. MV equals PY. And of course, some of these variables we have already seen before. Like so M is just our money, right? That's our quantity of M2. Right? That's our money supply. So MV is quantity of M2, money supply. P, we've seen this before as well. This is the price level. Y, we've seen that before also. Remember at the start of the semester, y equals c plus I plus g plus nx. We used y quite a bit. That was our real GDP. In some of the principle of macro courses, they actually would call it PQ. So they would say it's a measure of production. Either way, same thing. In fact, we've even seen PY as a variable together. Right? Like I said, if we called it PQ, maybe that relates a little bit easier to what we saw earlier this semester. But when we take production times a current price, we actually had nominal GDP. So that variable, that combined variable of PY is our nominal GDP. And again, you can kind of see the connection, PY, nominal GDP. When I base the price, I hold it constant, any constant value, so it could be 1. I would be left with real GDP, which was, remember our definition, it was nominal GDP at effectively a constant price. It's production at a constant price. So, so we've seen a lot of these terms before. already. There's one up here that we haven't, and it's this guy right here, V. V stands for the velocity of money. Does blue come out okay? Can you see it okay? Okay. Velocity of money. Maybe I'll lose it a little way, but the velocity of money is the number of times on average that each dollar is spent in a given year. The number of times on average that each dollar is spent in a given year. So, so velocity, again, it's annual in terms of a measure. It is an average in terms of a measure. And we've actually kind of did it, right? We passed around props from before, right? This guy, we kept saying, hey, these transactions are going through, and well, that money kept getting respent. And so while we didn't give it a name at the time, that's actually what we were measuring. The faster that that transaction goes, so if we could pass this through everyone in the classroom really, really, really fast, that would be a higher velocity of money. It's being respent faster and faster and faster in society. Let's just, for simplicity, just kind of like what we did, keep money constant if it was at 1,000. The faster that we could go through with these transactions, you know, if I had some cutoff amount, I give everyone 20 seconds. How many times can we pass it? The more times we pass it, the more transactions occur, the higher our nominal GDP. Right? If we were going really slow and it was like, here you go. Okay, here you go. And then I say, oh, 20 seconds. Well, we only had 2 transactions. We'd have a lower GDP. So the higher the velocity at some constant money, the higher the GDP. The more transactions you can have, the more sales that occur, the more production that has to happen for those sales to happen. Okay, so that's kind of just a quick take on velocity, but now let's think about it in terms of an applied. Velocity, we said, is a annual average. Again, so average, we're not talking each individual dollar, we're saying overall for society. It's an annual average. So at the time the Federal Reserve is making all of these changes, right, over the last 2 months or so, all of these money supply amounts have been changing, but the average for society, well, is going to be an annual amount. So if we say, well, we'll be able to look at any year, 2018, and say velocity was 6. Actually, I think it was a little higher. But we'll say velocity was 6. Money supply was changing all over, but our average for the year was 6, which effectively means that at any given point in time, velocity is constant. For that year, velocity was some constant value, you know, 6, 8, 4, whatever, I don't know. It was that constant amount, which means we can rewrite our equation of exchange as mv bar equals py. And then we can start looking at this, well, what if the Federal Reserve starts changing m? We said they can do it every day with the FOMC. Well, if v is constant and m goes up, mathematically, we know that py must go up. Py must go up. Okay, math says it has to happen. So now we want to know, okay, how? Well, we actually have 2 possibilities. I guess there is a third mathematical possibility. I'll address that with the brush off. We have 2 possibilities. Either price went up more relative to y. That's still saying they both could go up, right? Price went up 8%, y went up 3%. that would cause P, Y to go up. But in this case, it's saying price went up more relative to Y. Or we could say Y went up more relative to P. Right? Those are our two possibilities. And again, the third, I guess, mathematically exists possibilities. They went up the exact same. Sure. That could happen too. But I don't expect that. Right? Probably one of these two is going to happen. If price is going up more relative to Y, we probably have inflation. Prices are rising faster than production. If prices are rising faster than firms are producing, it probably means prices are going to be rising faster than wage growth. That may kind of put us into that, remember that reduction in purchasing power from a couple videos ago. If Y is going up more than P, we have production rising rapidly and price just kind of creeping along. We said prices are always going to go up. Well, this one's just price creeping on. We probably see, some kind of economic growth. I think that they like to call this economic stimulation, right? They're stimulating the economy. So we had these two possibilities for PY increasing. Either P was more relative to Y or Y more relative to P. So history has actually shown that these scenarios kind of play out in kind of patterns, so there's some predictability here. We tend to notice that, I'm going to start over with this one, that economic growth is the result if our country is experiencing a higher than normal unemployment rate. So if the unemployment rate is higher than normal, we have found that you can put money into society and it would stimulate growth and not necessarily lead to inflation. So that's kind of a little bit opposite of the graph we had earlier where we kept putting money in and dropping the value of money down. In this case, we find that adding the money in, that actually stimulates firms to start producing more to kind of account for or get some of that money as profit. They hire more people, and you end up with growth as opposed to inflation at a high rate. We find this is the result if unemployment is lower than normal. Effectively, if your unemployment rate is really, really low, putting more money into society isn't going to entice firms to hire anyone. They've already hired everyone they want to hire. There's not many choices left, if you will. So it kind of just says, well, more money is in society, we're just going to raise price as our methodology of getting that money into our revenue stream. So it kind of gives a prescription, if you will, for what the Federal Reserve should do. If you kind of think back again to the last video, the dates that I had, 2006 to 2015, what was the Federal Reserve doing? They were putting money in, money in, money in, money in. Why? Well, because during that stretch of time, we had the Great Recession and the after effects of it, where unemployment was, well, high. Even several years after, we had higher than normal unemployment. And so the formula says, put more money into society. Then in around 2015 or so, the Federal Reserve stopped. They stopped dumping money in society because unemployment got to kind of a low or a normal level. And then the formula says, hey, if you keep dumping money into society, you're going to have inflation. In fact, in 2015, 16, end of 2015, 2016, 2017, the Federal Reserve was actually slowly pulling money out of society, maybe to kind of curtail some potential inflation, again, to keep kind of that price level in check. So there's kind of a prescription of what the Federal Reserve should do. Should they be increasing money in? Or again, all of this could work in reverse. Should they be decreasing money? So that's kind of the initial look at the equation of exchange. Again, what probably most classes cover in a typical principles of macro. But since we didn't have that, I wanted to give that setup because we want to kind of take the next step. The equation of the exchange is really the first step in what is known as the quantity theory of money. And as we progress this semester with video lectures, I really think that I'm going to default more to algebra as opposed to calculus, because this is one of those things that we could differentiate that equation of exchange. You know, we could do calculus, get partial derivatives, and effectively find growth rates, right? I want to kind of steer towards algebra and away from calculus just because I think sometimes calculus would be tricky to communicate over video, and then there's risk of people getting lost and not having as easy access to getting the math help that they need. So I want to use kind of that idea of partial differentiation of this equation, and again, what that is showing us. And there is an algebraic, kind of quote-unquote rule, and I don't remember its exact name, but there is an algebraic rule that effectively is what the calculus is showing, that if I am multiplying terms together, it is approximately the same as adding the growth rates, which means that the quantity theory of money, and again, this is right where our textbook picks up with this, is effectively looking at those growth rates as that calculus approach, but algebraically as saying that the percent change in M, that would be the growth rate of M as a percent, plus the percent change in V is approximately equal to the percent change in P plus the percent change in Y. Again, there's a lot more we could do with this equation if we did the calculus. We actually come up with a formula for money demand out of this, but that's for maybe a different class someday. Again, some of these we already have terms for, right? So percent change, and this is the growth rate of money supply. Percent change in P, we already have that, right? That's the percent change in price. That's our inflation rate. And percent change in Y, we've done that one a lot. That's our real GDP growth rate. So a lot of these, again, we kind of already have terms for. I want to think about this percent change in V. Now, it does not have to be zero, right? So whenever we're looking at homework questions or whatever, test questions, practice questions, whatever, that doesn't have to be zero. But again, I want to look at it in an applied sense. If we are looking over the course of a year, V would be constant, which means that its percent change is effectively zero. If you have a constant variable, it doesn't change, right? 0%, remember, means doesn't change. It doesn't mean a value of 0. So it doesn't change. So while it doesn't mathematically have to be 0 in terms of an application, within a year, if V is constant, again, that's an if. So if V is constant, then percent change in V is equal to 0, which means we can rewrite this equation again, if V is constant, to show that the percent change in M is equal to the percent change in P plus the percent change in Y. I want to kind of do, a little bit of a mathematical twist here. I'm going to subtract percent change in Y from each side. And whenever I do that, I'm left with percent change in P is equal to the percent change in M minus the percent change in Y, right? All I did was subtract Y from each side. And then again, kind of go back to up here what I wrote in red in words. Inflation equals, I'm going to just say, is the result, right? The growth rate of money, sorry. And growth rate of GDP. So inflation would be the result. I would get a positive number here if the growth rate of money was bigger than the growth rate of real GDP. So, right, if this was 8 and this was 3, I would get 5% inflation. Now, if you kind of think about this variable, really easy to find. All of you have already done that this semester. We've gotten on the Fred site. We can access the growth rate of GDP. The Federal Reserve controls money supply, which means they know the growth rate of money supply. If they know these two values right here, the Federal Reserve effectively has a way of coming up with the value for inflation. And at the very, very, very start of inflation, I said we kind of had a goal, right? We like this kind of around 2-ish%, 1 to 3. Well, that's where that kind of goal comes from. The Federal Reserve effectively is controlling the inflation rate as well. Now, they don't completely control, because remember, the Federal Reserve never has any control over money demand. And if money demand changes, they may not be able to control the impact it has on inflation. But if money demand changes, they are pretty good at changing money supply to match that demand, which means effectively the Federal Reserve at least has significant influence on the inflation rate. It's going to make just a slight change to our mathematical formula. Remember earlier we said that the real interest rate was equal to the nominal interest rate minus the inflation rate. Remember, pi is inflation rate. We're going to put just a little bit of an E here. This stands for expected inflation rate. So our real interest rate is the nominal interest rate minus the expected interest rate, because again, the Federal Reserve is setting that to some extent. We can do a slight, again, mathematical twist here and say N is equal to R plus pi E. Remember we said N was effectively the bank promised interest rate? This is where they come up with that number. The bank says, well, what is the real interest rate, the real return? What do we expect inflation to be? Because the bank is going to account for that expected inflation in any interest rate that goes forward. Remember, we talked about your savings account and, well, that maybe your savings account doesn't reflect the inflation rate. The bank is a business. They are going to want to make sure that the expected rate is accounted for whenever they quote any kind of nominal interest rate to consumers.